So hopefully you apply this area addition postulate, which is basically just taking a non-simple shape and making it into simpler shapes, cutting it up into pieces. You'll notice this part here is not shaded. So whatever the heck this area is here, I'm going to subtract that out at the end. This yellow shape is actually a trapezoid. So you get different choices, and I'm not going to give you a formula for a trapezoid right now. I'm going to want you to make this into simpler shapes. You could easily just chop off this little triangle up top, and then you've got a rectangle and a triangle here. That's one method for getting this thing. I want you to do something simple like that. Cut it up into simpler shapes. Cut it up into parallelograms or triangles or rectangles and work from that. So that's my recommended approach. If you were to draw the altitude this direction in class, I'd say, how long is that altitude? And somebody quickly know, if this is 9, this is also 9. So you now have a rectangle here that's 9 by 8. 9 by 8 is 72 square units. And then you've got this little triangle, which is 9 by something here. Again, in class, I'd say, how tall is that right there? Well, if this is 8, that's also 8. If I take these 8 off of the whole 13, that leaves 5. This is a 5 by 9 triangle. So it's just, the big idea here is you take the rectangle area, add on the triangle area, subtract out that little square, and you'll get the total area here. So we mentioned the rectangle is 8 by 9, that's 72 square units. The triangle's 9 by 5, don't forget to divide that one by 2, and a square is just 16, 4 by 4. So hopefully you got 78.5 square units. We don't know if they're square inches, square feet, square miles, square somethings. Hopefully that makes sense. That is the area addition postulate. It basically says you can cut things into simpler shapes, complex shapes into simpler ones. Pretty straightforward, I hope. Here's a few good examples. They look a lot like the homework examples, homework problems, types of things you should be able to do. Let me give you some numbers to work from on these. There's all your numbers. Good time to pause it. See if you can work through these in any order you want. There are no other numbers you need on there. You can find everything else using analytical methods. So, nice little isosceles triangle here for the first one. You could call this the base, but you don't have the height. Again, good old trick here, draw your altitude. The 4, because this was symmetric here, the 4 got cut in half. So you've got 2 and 5. A little Pythagorean theorem will allow you to find that height. So keep an eye out. Anytime you create a right triangle, you can use Pythagorean theorem. Now you don't get a whole number for that. It's going to be 25 minus 4, which is 21. That height's the square root of 21, which is, 4 point something, 4.6, something like that. Whatever that decimal is, you'd multiply it by your base, divide by 2. I'm going to emphasize rounding these off at the end. You'll see I'm leaving this one exact. Most of the time, this unit, you're going to multiply those. So whatever 2 times that decimal is, that's going to be your answer most of the time. Sometimes we want this exact answer, sometimes we want the rounded answer. Second one, I would just say, let's call this the base. Draw your altitude here or out here. You can do either one. You take your pick. I think I probably drew it in the middle here. Of course, you know something about parallelograms. If these are parallel, these same side interiors have to add up to 180. And these opposites have to be the same. These opposites have to be the same. So you know that if this is 120, that's got to be 60, which bingo gives you a 30, 60, 90 triangle if you draw the altitude. And now a couple things you got to think through here. This is the hypotenuse of that right triangle. This is a 2 to 1 ratio with the shortest side. So this must be 4. I don't really care, but this leftover piece here would be 6. Doesn't really matter. But this is 4. And this has to be rad 3 times as long as that. So 4 and 4 rad 3 would be your missing dimension on there for height. Pretty straightforward from there. Again, I'm going to leave this one exact. I'm not going to turn it into decimals. I just do my base, which was 10 times 4 rad 3. I've got 40 rad 3 square inches. Again, most of the time I'm going to say multiply these decimals out. If you did this with trig, you'd have a decimal here. You wouldn't be able to get that precise answer. All right, the last one involves a couple Pythagorean triples. So this shape, you might look at it and go, what the heck is that thing? Technically, it's a trapezoid, but I don't care if you know if it's a trapezoid because you can see it's 2 different triangles with the altitude drawn right down the middle. So you've got to find that altitude length probably using these two. Again, 100 minus 36 will give you 8 for that dimension. And then you can use these two dimensions to get to this base of this triangle. So 17 squared minus 8 squared will eventually get you 15 for that length. And again, I'm calling h this dimension here. Maybe that's not an h, maybe that should be a b for base. I don't know, it doesn't really matter either way. You've cut it up into two pieces on there. And then find your two areas and add them up. So this is 6 times 8, 48 divided by 2. Don't forget to do that. 8 times 15 divided by 2. So those two areas, the top one's 24, the bottom one's 60. You can see the bottom one's a little bigger anyway. It should be 84 square units, whatever the heck they are. Hopefully that makes sense. You know, like I said, not a middle school problem. These are multi-step problems, many layered problems on here. All right, I'm going to come back and finish this last one in a minute. This next one, I should say, in a minute. There's your dimensions in terms of x and y. Your answer for this one is going to be in terms of x and y. So you're not going to solve for x, you're not going to solve for y. Your answer is going to have x's and y's in the area you find at the end. Good luck. Use the area addition postulate.